So in this video, I'll be demonstrating some of the basic functions on the working parts of the synthesizer. So I'll start with the oscillator. It's currently set to a square wave output, and you can see the peaks and the troughs here, which give a nice geometric shape. I then have pulse width modulation control, and you'll see that one end the peak gets wider and the troughs get thinner, and then the reverse, as you can see there. I also have a ramp wave function which works on this oscillator, which you can see quite cleanly there. And then it's a much lower signal, but there is then the sawtooth wave. Unfortunately, there is no output from the sine wave. It is just a complete flat ground connection. And then the triangle wave is very hard to tell if it's really a triangle wave or not, because it has a very strong appearance to a ramp wave. However, I've not been able to fully test it yet, and it is again at a very low output voltage. Now, the other parts of the filter that are working are, you may notice the light stepping along on the sequencer. That is stepping along correctly, like it should be. However, I can't actually get a voltage I can use to control the oscillators with out of the outputs yet. I think I know the reason for that, and it's because of how I connected the LEDs to the potentiometers. I connected them in parallel, but I think if I connected them in series, it would work slightly better. But I'll have to figure that out another time. The other signal I can get out is the clock for the sequencer. So you'll see it's reading high and low there. I can speed the clock up. So you end up with a pulse just like before. And there's a very large range for frequency on this pulse. Now, the other part I'd like to demo is the VCA. So the VCA is the voltage controlled amplifier. So there's two ways I can actually control this, and this is just the square wave output from the oscillator again. So you can see that there. The first way is with this potentiometer, and it brightens the LED as you increase the voltage, which you can see happening there. The second way is to use an external voltage source, and for that I'm taking the clock output from the sequencer and connecting it to the VCA's input, which you will then see is stepping through like so. I can also then increase the offset on that. I think I've got a loose connection there. Hold on. Yeah, but the other part of the circuit that is working is the filter. Or specifically, it's the high-pass filter which is working. So if I connect that in and get back to our original signal, now if I slowly start to filter off more of the square wave because it's a high pass, we end up getting more and more of a notch. Let me swap to the clock output because it can be slightly easier to follow. Now, it can be a bit glitchy and hard to find a signal sometimes. I'll go back to the oscillator. Here we are. So this is the ramp again. And as I start to cut more and more from the high pass, you'll see that it changes shape. And if I bring it back just a little bit, you can see that it's kind of now got an arch on the top. I can also increase the resonance, which just exaggerates the frequency that I'm cutting there. And that looks like that. Unfortunately, I can't get the low pass to work, so I can't demo that, unfortunately. But I can also demo the voltage control for the high pass. So this is just using the clock from the sequencer again. So every time the clock steps through, it activates the filter, and I can speed that up. Like so. But those are all of the all of the modules I'm currently able to test on the synthesizer. I do plan on going over all of them and repairing them and ensuring that they work at some point. However, I currently don't have the time for that, so I'm going to have to leave this project where it is currently. Although I do feel I've learned loads from this entire project.